Hey guys, Code Arcanus here. Welcome back to the workbench. So today we've got another one of these mystery circuits. Let's see if that one focuses. Yeah, there we go. So this one's an interesting one because it's a bit more complicated than the last one. It's got one of these things. So it's a LM358. So if you look at the data sheet, that is a dual low power op amp. So it's operation amplifier. It's got two op amps in it, VCC ground. And what's this one good for? 3 to 32 volts input. Now, when I opened this kit, I could have sworn there is a 9 volt battery adapter with it. I can't find it. I think I've used it in another kit. But never mind. Let's just carry on. So let's flick back to the workbench. So again, it's not particularly complicated circuit on the back. So yeah, a bit of deciphering, and that's a circuit board. Oops, I forgot. There's 4 LEDs. So yeah, it's an interesting one. I'm going to be honest. It's been so long since I've done a huge amount of stuff with the op amps. I kind of struggled to figure out what this circuit does, and I'm still not 100% sure. But voltage in here through a little resistor there. And yeah, we have basically, it's very similar to the last circuit. If we ignore all that, we have a transistor switching LEDs on and off through to the power supply. So, yeah, voltage divider here. So these two are connected. The op amp is connected into the same voltage potential. So if this is 9 volt, we can ignore that really because that's not hugely comparing to these two. So that's going to be roughly 9 volts. That's going to be 0. That's going to be roughly 4.5. So there's a midpoint. These two things. That first one's an integrator. So if you ignore everything else down there, that's an integrator. So as voltage comes in, this will slowly charge up. Is it an exponential or that way? I can't remember exactly. But this is an integrator, so this one will go upwards. This one here takes the output of this one, feeds it back into here, and then feeds it to the other side of the op amp, other side of the capacitor, which means at some point, if this voltage is higher than that voltage, it should stop charging. But again, I'm not really sure how this is going to work because I said I've kind of forgotten how op amps work. But wherever you see a capacitor and a resistor in this little circuit, I will bet my bottom dollar that we've got some sort of oscillator or timer going on here. I think it's probably an oscillator because I can't see a reset button anywhere. So I think this one will probably have some sort of maybe sine wave through here. But my plan is to get this up, get this created, get this working, and then fire up the oscilloscope, put a few points on here, and actually see what it does. So, stay tuned. Let's get this built, and let's figure out what it does. Or let's see it working at least. Right, let's turn the soldering on. Oh, right. Come on, click. There we go. Get the old solder out. So, what do we have here? We have 75K, some 47Ks, and 247. So, I'm going to hazard a guess that that is a 75. We've got 2 47s and 3 47Ks. So that'll be a 47K, I suspect. That'll be a 47s, and that'll be a 75s. Now, coming back to my diagram, 47, 47, 47. I'm missing a capacitor. Hang on, where's my initial drawing of this rough one? Oh, I can see what's happened. Yeah, I've missed. There's actually a 47 ohm there. That explains why there's two 47s, three 47Ks, and a 75. Oops. That's what happens when you redraw stuff from diagrams. So, right, let's just fire up the resistor color chart because I can never remember this. And let's have a check. So, that one, what we got there? That is a brown, red, black, green, is it? Looks like it. So brown is 1. Oh, I got that the wrong way around. No, that should be right. No, it's brown to me. Brown, red. Red's 2. Okay, that one doesn't make sense. 1, 2, 3, 4, 5 bands. Tolerance looks like it's gold. Might be what, 2%, is it? Oh, wow. Okay. So that's right. So it's yellow, violet is 4, 7. Black is 0. Red is 2. Yeah, so it's 4, 7. Oh, because these are 5 bands. Oh, I'm looking at the 4 band. No, it's not a 6 band. 5 band, here we go. View image. Right. So let's start this one again. So this one is yellow violet, so it's 4, 7. Third digit is a black, so it's a 0. So it's 4, 7, 0. Followed by a red, which is 2 zeros. So it's 4, 7, 0, 0, 0. So that's your 47K. And this will be yellow, violet, black. So that's 4, 7, 0. And let's say that's gold, so it's 0.1. So that's 470 divided by 10, 47K, 47 ohm. So this one is a bit confusing. Because this is meant to be 75. How about we turn the right way around? So that's violet. It's a very weird violet. But anyway, violet green, 7.5, yep. It's black for 0, 2, 750. And that must be what? Brown? Don't have a brown on my list. That's a tolerance, and tolerance I'm a bit confused with, but never mind. So we're right, 75, 47K, 47. We have some power supply leads, op amp, 4 LEDs, and the pot. So let's get the resistors in first. So let's start off with the 75. Where have I put my resistor bender? I've put it away, can't be bothered getting it, it's too late. So 75, there, oh, they're in, there, there, and there. And that way around. Well, these are big holes for these resistors. And what I mean by that is the actual out legs are quite small compared to the holes, but never mind. And then these are the 47Ks. There. 47K there. Where we got another one. 47K, that one. Last but very not least, another one. Let's see, 47K goes there. And then a couple of 47s. Right, 47, 47, 47. Where are we? There. Okay. For that one. Yep. And then last one is right in the middle. 47. So just make sure we got 47K, 75, 47K, 47K, 47. I mean, whoever designed these boards have done a decent job at labeling everything. It's nicely laid out so I can understand it, which is cool. All right. Let's get the slots sorted up. And are we up to temperature? We are. Right. Let's start with this one. Oh. Oh, come on. I think these boards have been around a while. I may have had them for a few years. Come on, touch sleep. There we go. Oh, come on. Okay. Get in there. Come on, touch sleep. There we go. Touching both at once. Nope. Okay, that's that one done, that one done. Right, let's fold. Let's get these ones done. Two almost touch, well, they are actually touching and connected, so they're going to be to get sorted, but we have ways, we have means. Right, let's get these ones out of the way. Done. Oh, no, come on. Done. Done. Okay. These ones. Put that one that way. That one there. That might work. Let's see if I can't be cheeky and do two at once. No. Come on. There's one. Ooh, they don't want to flow nicely. Right. Good old-fashioned liquid flux. Let's see if that can clean up that joint a bit. Oh, great. It'll do. Good enough for Australia, as they say. Yep. Right. Wire cutters. Let's trim all this lot off. keep these little wire. Can't remember who I was watching. Someone suggested just keeping all these little wire offcuts. Really useful if you want to put making jumpers for anything. So I just keep a stash of all the leads I've cut, and then where I need to put jumper wires down somewhere, I've got a nice little stash of them. Right. Oh dear me. That's not great, but though let's just clean up some of the flux to start with. Let's see where we are. Right. Okay. Nope. So there's the resistors down. Straighten that one up a bit. Looks a bit worse. No, a bit better. Right. What do you reckon? Let's put the chip in next and see which way around. That way around. Better get that around the right way. Right, there's the chip. Let's get that soldered in. Let's be nice and quick with that so we don't get it too hot. It's been a while since I've played with op amps. Really need to get some and start playing around with them again. Oops. Remind myself how they work. Most of my circuitry these days is fairly, well, the stuff that I design is, I tend to cheat and put a microprocessor in the middle, and the actual comparison of voltages and all that sort of thing, amplification. I don't do any audio stuff these days, so. Right. That's in. Let's get that soldered in. Wow. That's chunky. Oh. Chunky pins for the old pot. Come on. Yep. It's nice about having a fairly chunky soldering iron. It heats up these bigger joints, all right. And the last one. Although it is temperature controlled, so I can't remember what's it. It's a knockoff of something. That looks pretty good to me. Right. For these, positive is the big one. Come on. 1, 2. Three. Come on, slide. 3, 4. Come on, there we go. And now let's get these 4 in, and then I'll put the cap and the transistor in. We'll see what we're up to. Just sit there. Thank you. That's 2. Come on. There we go. 3. That's actually not bad. 4. Yeah, that looks pretty good to me. Let's trim those and get them out of the way. Pretty good to me. Come on. 1. Come on. 3. There we go. Last, lucky last. There we go. Reasonable joints all around so far. What have we got? And some wire. Let's separate that. Separate that. Right. Wire that up to the power supply in a minute. This will be my power wire. Plus or minus, oh, plus or minus, plus 5 volts. Anyway. Right, and let's see. That way around. You come up from there, then down. Oh, way too much. You come out from the same sort of place. And then drop down. Weird alien, but never mind. And oh, 1, 2, 3. Right. Put it in. You stay there. You stay there. Right. Let's get this lot sorted up. Yeah. How'd that look? Whoa. I mean, one's taken no solder. Interesting. Oh, that's better. These holes are very, very big compared to the size of the component leads for some reason. Although the capacitor ones are actually quite good. Right, that's good. No. Trim those off. Oh, a bit drunken there. Drunken there, but never mind. We'll just leave that a bit drunken, but never mind. That looks pretty good to me. Don't think we have a short. No, I think we're right there. Let's just give that a quick scrub, make sure. Right in there. No. Pretty close though. There's a gap there, but man, that's a bit close. Anyway, that's good to me. Right, what we got? I'll make ground brown, why not? Ground VC. Oh, if I twist the wires up. Ground and VCC. Right. get VCC. Locked you down. Right. All right, come on then. That's one. That's the other. Not too much melting. That's pretty good. Turn the old soldering iron. Trim that one. Nope. Trim that. Right. No shorts. Right. Let's see. Drag out the crocodile clips. Let's see. It's negative. So what do I say? Ground is brown. Actually, they're short. Right. Let's see. Voltage up to 9 volts. Turn on. So it is an oscillator. And we do have, just hold it up here, make sure they don't short. There we go. It's slowly pulsing on and off. And what's the bet if I find a screwdriver around here? Oh no, that's way too big. Screwdriver. Just be a second. Screwdriver. Here we go. Nope, that's Phillips. That's a pointy. Wow, here we go. So if I crank this around to one way, okay, it speeds it up. Cool. Right, so what we have is exactly as we thought. One of these is pulling this discharging the capacity, the other one is charging it up, causing one of the other ones. But yeah. So what I'm going to do now is I'm going to pause the video, tap some feeds off it, get the oscilloscope fired up, and let's have a quick look and see what's going on. So I shall be right back in a second. Right, so a bit of playing around and wiring up stuff later. I now have my board probed. As you can see, it's chugging away here. Big feeding frenzy of ground leads at the top and circuit boards. So what I've got plugged where at the moment is, so channel 1 is on the base of the transistor, basically the output of the top op amp, which I have found. I shall label them. This is op amp B and that's op amp A. So that's op amp B. So 1 is currently on the output of op amp B. 2 is on the negative input of B, so basically the base of that capacitor. 3 is on the non-inverting input of op amp A, so the feedback loop from all the slot, which should be fairly close to 1, I suspect. And then 4 is the output of A at the base of this pot. So now if we switch to the scope and have a look, I've paused it so we don't end up with a lot of refreshes. So as you can see, yellow is the basically the input of the capacitor, the base of the transistor. So this is what the LEDs are seeing. So it's up, down, up, down. So it's on, off, on, off. This is in 2 to 2 volts. So it's 0 to 8 volts. So this is pulsing. What's that? Just above 2 to just below 6. B, which is the base of the capacitor, sorry, 2, which is the base of the capacitor, which on this one is 2, as you can see, is base capacitor is just varying away slowly, which is interesting. Now, the interesting one also is 3, which is the pink one. So this is the input to, let's just flick it up. So 3 is the, pull that back. 3 is this one here, the input to the non-inverting input of op-amp A. As you can see here, it's going pink. So it goes down and ramps up slowly, following, funny enough, the output, because it's linked to it. And when it hits about here, it shoots up, goes down, shoots down. So it's basically following that. And then this here is the output of the first capacitor as it drops down. So look, it sucks the value of that capacitor down. Then when the capacitor gets down and hits the pink, which is the 3, it switches to maximum output and raises up, which as you can see causes the capacitor to charge, down, causes the capacitor to discharge, up, causes the capacitor to charge up again. So the output of the, let's flip back to the workbench. And as we were saying before, the output of this here, this one here, is causing that capacitor to charge and discharge. And that then causes this to just vary up and down, slowly turn these on and off. Yeah, I'm sorry if I'm not explaining it very well. I really need to get back into figuring out how these op-amps works. But anyway, there you go. Please leave any comments you have below in the comment section. If you can explain how the system works, please do, and I'll gladly credit you with the explanation. But yeah, it's interesting. You can see the nice sawtooth there, but anyway, it was an interesting build. Yeah, as I said, looking at the circuit diagram. Now flick it back up. Just looking at the circuit diagram, it's the minute you end up with the capacitor and resistor, it just screams oscillator. And also looks vaguely, and I need to try and find it looks very similar to a 555, the old, I think it's just because of this voltage divider in here. I think 555 has another, yeah, because it's 5K, 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 so 555 has another input here, another resistor here to give it the hysteresis. But yeah, interesting circuit. I enjoy building it. Sorry if my explanation of how the circuit works is a bit vague, but to be honest, I have no idea. I know it's got an oscillator in it. I know it's got one op-amp switching from charging to discharging to charging to discharging, but that's about it. It was fun to build, fun to play with, fun to explore how it kind of works. And yeah, like and subscribe, leave any comments below, and I'll catch you guys later. Bye.